Okay, I'm going to get through this very basic math lesson as quickly as I can. We're going from super duper duper basic and we're going to work our way up. Those of you who know what you're doing, I suggest you still watch this, because if you ever go into education or want a tutor or anything like that, it might be a good idea so you have some ideas of how to teach other people. All right, so is this curlicue equal to this curlicue? Yes, right? Obviously. Why? They look the same. Is this curlicue equal to this triangle? No, they are not equal. Why? Because they look different, okay? So let's match these options here, right? A, this looks like this A, so they match. This negative A looks like this negative A, so they match. Negative X looks like this negative X, so they match. This X looks like this X, so they match. This is all very obvious, duh kind of stuff, but now we're going to talk about why that matters. That is because these, what are these? They could be variables. Anyone who's been through algebra would think of these as possible variables, but what we're going to call them is terms, right? These are all terms. What is a term? A term is a configuration of lines. That's all it is. It's configuration of lines. It doesn't matter what that configuration of lines looks like. So let's write this. Configuration of lines. It doesn't matter what it looks like. It could be a cloud. It could be a triangle. It could be pony farts. It could be anything. It could be blob. It does not matter what it is, okay, for our purposes in this lesson. So we're going to call these things terms. It's a configuration of lines. It doesn't matter what it is. And that's because when we go to equate these things, A equals, let's give it a value of 4. If we're looking at another equation down the line in a math problem, and we see y equals 2a, what do you see? The same configuration of lines, right? It's the same configuration of lines. 3 lines, 1, 2, 3, 1, 2, 3. It's a term. So you can equate it to the number 4. This is the substitution property in math, okay? We'll talk later about substitution. It's all we're going to cover for the moment being, okay? Terms, configuration of lines, does not matter what it is. When you see it, 1, 2, 3, configuration of lines, 1, 2, 3, configuration of lines. It's equal to something, that something can be substituted in directly. All right, now let's come up here. What do you see? Hopefully, everyone logically says X. That's probably what you see. That is not what I see. Now, if you come down here, what do you see? Everyone is going to say 2X, right? Some of you who are thinking maybe a little more broadly is going to say 2 times X. And when you're thinking about that in that direction, you're on the right track. So 2x equals 2 times x, okay, equals 2 times x equals 2 times x. However you learned your nomenclature through school, it's all the same damn thing, okay? Now after seeing this, now what do you see? Hopefully you see a 1 before this x, because this is 1x. This is 1 times x. So x equals 1x, which equals 1 times x, which equals 1 times x, etc., etc., etc. There is an understood 1 in front of that x. Okay, if that is the case, now what do you see here? Well, some of you are still going to say negative 4x, right? There's actually 3 terms here, okay? Not just negative 4 and x. There's 3 terms. You have a 4 and an x, and then you have a negative 1, okay? So, switch colors again. This is a negative 4x equals negative 1 times 4 times x. Okay? There's actually 3 terms in there, all squished into 1. Okay? So all of this again, when you multiply all of that, it's going to equal this. Negative 4x. So if I were to ask you, what is negative 9x squared? You're going to say negative 1, 9, and x squared. Negative 1, 9, x squared. Just like negative 4x, negative 1, 4x. Okay. Let's take you back to 3rd grade. We're going to cover real super duper basic. 2, and this is the whole numbers fractional situation, okay? 2 is not just 2. 2 is 2 over 1. So you've got your fraction here. 2 equals 2 over 1. Why? That is because the fractional bar, this little doohickey, means divided by, okay? 2 divided by 1 equals 2. 2 divided by 1 equals 2. So, what do you see now? 2x. So you know that 2x is going to equal 2 times times x, that 2, you know, is 2 over 1, right? So 2 over 1 times x. So it's 2 over 1x. Just like up here, this x is technically 1 over 1 times x. This is negative 1 over 1 times 4 over 1 times x. And technically speaking, the x is also over 1. All right, continuing. What in the hell does reciprocal mean? And why am I talking about it? Reciprocal in math means to flip, or the reverse of. So in fractions, the reciprocal of 2 is going to be 2 equals 2 over 1. Whenever you flip that and take the reciprocal of that fraction, the reciprocal is going to be 1/2, or 1 over 2. So that is the reciprocal. Why are we talking about it, right? Well, this is why. If we're over here, back over here, down at this equation doohickey, y equals 2a. We're going to use that example, okay? Y equals 2a. Some of you learned there are 2 different schools of thought: divide by the whole number or multiply by the reciprocal. Depending on the age of your teacher, how they learned it in school, or the curriculum that they were requested to teach you with, they taught it in 2 different ways: divide by the whole number or multiply by the reciprocal. So if we're looking at this, if we're trying to find the term a, if we're looking to find the term a, then we need to scoochie-woochie this number 2 over, right? We gotta whoop it over. So, school of thought number 1, divide by the whole number. This is a whole number, okay? It's 2 over 1. It's a whole number. So, what are you gonna do? Divide both sides by 2. And then you're gonna have a equals y over 2, okay? That's one way. Now, school of thought number 2. Multiply by the reciprocal. So as we said, this number is 2 over 1, okay? 2 over 1, let's write this. 2 over 1 times a. You're going to multiply both sides by the reciprocal of that. So you're going to, I hate doing it this way. I did not learn it this way. Multiply it by the reciprocal. We're going to flip this. 1 over 2. Okay? 2 over 1 times 1 over 2 cancels each other out. Whoop. They cancel each other out. All you're left with over here is a. Now you're multiplying this by the reciprocal, 1 over 2. Okay? Y is now, or this side rather, is y over 2, or y times 1/2. So simplified, this is going to be a equals y over 2. The exact same thing we got in the other manner of doing this. That is why I just went through fractions and taught reciprocals. Okay, moving on. Maybe I should leave this up. All right. give you a second, and then I'm gonna turn the whole thing and face that board. Okay. All right, let's turn. Hopefully I can do this without disturbing anything too much. Okay, so here we are. A lot of people don't, sorry, I'm gonna get stuff out of the way. A lot of people don't understand positives and negatives, how to switch them around in an equation or just in general, what they mean, how to play with them, how to get them to work to your advantage, right? So we're gonna cover that. So this is what I call playing with positives, okay? What do you see? Hopefully, when you see this number, you're gonna say 1, right? Because that's logical. And hopefully when you see this number, you're gonna say -1. Hopefully you don't say -1. It's not -1, it's -1, okay? Now what times what equals a positive? I hope and pray to God that you were taught this in school. If you weren't, it is a travesty. Okay, what times what equals a positive? Up here, let me come around. A negative times a negative equals a positive. Okay, these negatives could be anything. It could be -5 jillion times -2 equals a positive number. It is a positive number over here. A negative times a negative is a positive. So now, when you look at this number, hopefully you're going to see a, quote, +1. So you see this number, you think of it as +1, and all of a sudden you're like, positive, holy shit, I can play with positives. Okay, now what do I do? Well, there are some ways to think about this, right? If it's a 1, it's obvious. -1 times -1 is a +1. -1 times -1 is +1. Now here, when you see this, obviously you saw -1. As we said over there, hopefully you said -1 and not -1. It's a -1. So up here, as we were kind of doing a little equation over there, dividing by a whole number or multiplying by reciprocal, same idea goes for here, okay? If you want to make this side negative, you can divide by a negative. Make this side negative, okay? It's the same idea here. Negative times a positive equals a negative, okay? So, when you're looking at this number, 2, what do you see? Well, it should not just be 2 numbers. You should see 3 numbers, right? To give you a little bit of wiggle room to play with numbers and things, right? So you should see a +2, obviously. You should also see a -1 and another -1. -1 equals a +1. +1 times a +2 equals a +2. There's another option. -1 times -2 equals a +2. So you have a couple of different options to wiggle around your equations to be able to fit things in. All right, now this is super duper basics. And next, we're going to move into more difficult things and start working through some other issues that are going to lead into this chemistry problem. This is a chemistry 2 problem. Some of you who are accessing this video are from University of Southern Mississippi, and you were told about this video by me. I'm in your class. I'm 32 years old. I've been tutoring math, K through post-grad, for 15 years now. And we're going to work through this problem together. This might be a couple of videos from now. We're gonna build up to it, but this is super duper basic math, okay, that we just went over. I mean, like I said, we were talking about fractions and reciprocals. That is 3rd grade level math. Okay, we're talking about matching terms. A equals A. Negative x equals negative x. Very basic things here. Next, we're going to move into substitution. A little more substitution, fancier substitution. We're going to cover what is the language of math, which is kind of a term that I coined because I think it's something everybody needs to learn. People have a tendency to write math non-linearly. They write it across and they screw themselves up and they get things mixed up and they lose positives and negatives and divisions, and they don't remember what "please excuse my dear Aunt Sally" is. So we're going to cover all of that because you're going to need that, and we're also going to need the rules of logarithms. We're going to need exponential rules, and we'll touch on a few other things, but we're going to build up to it. Obviously covered super duper basic things, and we're going to move slow. All right, this is part 1.